Hi, good morning. I'm Ahmad. I came from École de Technologie Supérieure in Montreal, Canada. First, our group is a multidisciplinary group, includes chemists, electrical engineer, and computer engineer. And today I'm going to share with you the recent development that our group is doing for developing a meat packaging to monitor meat freshness. Okay. So food insecurity is one of the serious challenges facing humanity in the coming years. While there are 2 billion people suffering of food insecurity worldwide, almost half of them suffer of severe food insecurity. This challenge is not limited to specific culture or country, as a recent study showed that more than 30 million US citizens experienced food insecurity in 2021. At the first glance, it looks like we don't produce enough food to feed people, but the reality is we waste one-third of our food production. That reaches 60 million tons in the United States alone and exceeds $200 billion. The good news, with better management of food supply chain, we can reduce the food waste and its related cost. Among the food waste, our group is interested to improve the meat supply chain because meat has the highest cost, most sensitivity to environment conditions, and shortest shelf life. With the scientific advancement and the revolution of sensors, scientists brought the concept of using sensors to monitor the meat environment in order to detect, analyze related to meat freshness. This concept is really, in the recent years, became very attractive. Event proved by exceeding the number of publications that exceeded like 200,000, or the number of patents that exceeded 100,000 patents related to food packaging. The expected market size for global meat safety testing market, including the meat packaging, is expected to increase from 4.4 billion in 2020 to almost 6 billion in 2027. And in the recent years, there were several startups working in developing meat packaging using analog or digital sensors to monitor meat freshness. Taking part of this development, our group has the expertise in materials engineering and using well-developed innovative printing technologies. This combination, successfully, we could produce various flexible sensors that have high potentiality for different applications, including but not limited to food packaging. In our meat packaging, we use three sensors: the hydrogen sulfide gas sensor to monitor the meat freshness based on the hydrogen sulfide gas concentration. We use also temperature and humidity sensors as a standard environmental sensors for the package. We developed our sensors using well-engineered nanocomposites that carbon materials, either graphite, graphene, carbon black, or carbon nanotubes, occupy significant parts of our sensing nanocomposites that give the dark color for our sensors. And we used different printing technologies, doctor plates, 3D printing, aerosol printing for our sensors fabrication. We made a complete study to prove the efficiency of our sensors for our suggested application, and most important, the sensitivity. Hydrogen sulfide gas sensor showed a high sensitivity for gas concentrations below 100 parts per billion at room temperature. The temperature sensor showed high sensitivity from minus 10 degrees to 60 degrees. The humidity sensor showed a high sensitivity from 10% to 90%. Because of the limited time, I will share with you individual testing for our sensors in different applications to convince you that our sensors are efficient for our suggested application for meat packaging. I will start with the hydrogen sulfide gas sensor, which is based on indium oxide and graphite nanocomposite. We started developing our sensors since 2018, and we made a series, various publications showing our sensors development step by step. And we use it in two main applications in food packaging, and we use it also for breath analysis. This one shows our sensor performance for food packaging with beef meat. And we compared our sensor performance in the red curve with the Figaro reference sensor, the Figaro gas reference sensor. And just by quickly that our sensor showed increasing in the gas concentration in the first day of incubation. And after 2 days, the sensor response increased significantly, indicating that meat is not edible anymore. The temperature sensor, which is based in graphite polystyrene nanocomposite, we use it also in different applications in monitoring temperature for solid objects, like the one attached to a beaker, and other also for breath analysis. For the monitoring temperature for solid objects, here we started adding like hot water, cold water to monitor our sensor performance. And breath analysis, we compared our sensor performance, the blue curve, for normal and slow breathing scenarios, and we compared its performance for a reference temperature sensor. And just by comparison, our sensor showed a close match in performance. Last year, we shared 2 publications for our temperature sensor, and this year we submitted our complete study for our sensor. Our humidity sensor is based in graphene gelatin nanocomposite, and also we tested different applications. One of the most interesting one is using for breath analysis, and we made a comparison for non-smoker and smoker individuals. So we found that there is a variation in sensor response based for these 2 individuals. Quickly, for example, for the normal breathing scenario, the non-smoker had a higher response than the smoker individual. For slow breathing scenario, the non-smoker had a more stable sensor response than the smoker who had a continuous reduction in the sensor response. For gasping, it was a close match in performance. So which can be by monitoring humidity and our breath, we can maybe also indicate our lung functionality. We shared also 2 publications about our work, and this year also we submitted our complete study for the sensor. So then we took these sensors, we put them in our meat package, and we started testing them with the various meat products, chicken, beef, fish. Also, we tested them repeatedly to confirm their reusability. We also tested them in long and short-term scenarios. So in long term, we used fresh meat products like chicken, and we started also observing their performance. The hydrogen sulfide gas sensor, which is the blue curve, showed a close match to our previous observation, also aligned with the sensor calibration. But for our humidity and temperature sensors, they showed odd performance, first by fluctuation during the test, and they couldn't recover their initial signal during the long-term test, indicating maybe they are not practical for long-term testing, and we need to improve them further. But when we test them in short-term testings, for example, using relatively expired meat products like chicken breast, the hydrogen sulfide, again, it showed a very quick response because the gas concentration was higher than the fresh one. The humidity sensor showed a high performance that by increasing the humidity during meat incubation and recovering the signal after removing meat. Temperature sensor also showed a similar performance by increasing with the meat incubation and recovering after removing the meat, indicating if they are not practical for long-term testing, they can be usable. Can be beneficial for short-term testing. And we continued our testing for different scenarios, different meat products. This one for also like a relatively expired tuna fish. And again, the sensors showed a close match to our previous test observations. So what's next? As I said, like our group is not just a chemist. By myself, I'm a chemist. But we have also engineers, electrical and computer engineers, and they are working now together to reduce the size of our packaging. So it is relatively complex with the Arduino, with the cables. Our sensors now in centimeter scale. Of course, with the cable and PC for study our sensors response. Now they are making them in centimeter, the whole device. We are making them in centimeter scale. Our sensors will be printed in micrometer scale in this small part. Students, they are now developing to make it, of course, like wireless and connected with smartphone applications to monitor our results performance remotely, and they are now developing algorithms to provide numerical and understandable results. So at the end, I wish if I could at least showing that we have a promising food packaging, that we are still working to improve it further. We are making now the devices smaller, wireless connected with smartphone applications, and we also trying to make it how's that as portable to be used like in a small meat packaging. And then I want to thank my advisor, Ricardo Izquierdo, for his support, my lovely group for their contribution in the work, and thank you so much for your attention.